Back again with AP Economics. We're talking about interpreting the elasticity of demand, and we're on our second part now. Okay, so moving on. So if you haven't looked at part one, this is a continuation. Make sure you do. Okay, we have an example, a graphic example of this. Okay, in this case, we're charging $2 and we sell 50 slices of pizza. 2 times 50, there's $2. There's 50 units, and that rectangle there, total revenue is $100. Okay, that's how it looks. That's how you should think about this. Okay, now we want to earn more revenue. What would happen if we raise the price? Well, let's see. Well, it turns out if we raise the price to $3, we sell 40 units of pizza. So we were selling 50, now we're only selling 40, but we're selling them for a higher price. How'd that work out for us? Well, 3 times 40 is 120. We were making $100, now we're making 120. I'm happy, right? I'm making more money. I'm selling a little less pizza, but I'm making more money, and that's a good thing. So I have a gain of $20. And the reason is I raised the price from $2 to $3, that's 50%. Well, the quantity demanded dropped from 50 to 40. That's only about 20%. So 50% is greater than 20, and we end up with more, okay? And if you think about it, so we sell 40 slices for $1 more. So 40 slices, and we got $1 more each. That's $40. So we gained 40. Now, we sold 10 less pizzas, right? So 10, quantity of 10 that we sold less, but we're only selling them for $2 a piece, right? So that's minus 20. So sure enough, 40 minus 20 is $20. 100 plus 20 gives us 120. So there's your price impact and your quantity impact. That's how it looks, okay? You're probably not going to have to do something exactly like this, but it helps if it makes sense to you. Okay, this is called the total revenue test. Make sure you have this down because this is really important, okay? And I got my little helper right here to show you how to do it. Okay, if the price rises and the total revenue rises, what do I look like? I look like an I. That means it's inelastic. If the price falls, the total revenue falls. What do I look like? I look like an I. That's inelastic. What if the price rises and the total revenue falls? I no longer look like an I look like an E. See, kind of like an E, okay? Or if it works out the other way, then I look like an E going the other way. Doesn't really matter, okay? If they both go up, they both go down, inelastic. If not, it has to be elastic, okay? You need to know that. That's important. The total revenue test, very important because it's a little bit easier than the coefficients of elasticity where you do those calculations. But big thing you have to remember, right? What goes on top? Percent change in quantity. If you remember that, the coefficients aren't too bad either. Okay, so now let's look at the total graph and see what happens. Okay, we already said the midpoint is unit elastic, the left side is elastic, and the right side is inelastic. How does that work? Okay, well, you think about it over here. We start off at a very, well, actually, let's start over here at a very low price, okay? We have a very low price. We sell lots of quantity. So if our price is $1, we sell 60 units. That's $60 in total revenue. Okay, and they calculated the price elasticity of demand over here. And you notice it's less than 1, which means it's inelastic, which means we should be able to raise the price. Let's see. Well, let's raise the price to $2. 2 times 50, go to 100. That's plus $40. That's good. We have more. We raise the price, more revenue. Okay, we're still inelastic. Price increases, total revenue increases. Let's try it again. Raise to $2 or raise to $3. 3 times 40 is 120. We gained another 20. Price increase, total revenue increases. Yay. Okay, let's raise it to $4. Now we're only selling 30 units. That's 120. That's plus 0 and actually gives us a coefficient of 1. That's unit elastic. So we're going to have the same revenue whether we sell it for $3 or $4. because the income or the price effect and the quantity effect offset each other. Still trying to do it. Okay, here we go. So let's continue. Okay, now we're going to move down to this side of our equation. What happens if we keep raising the price? Well, now we raise the price to $5. Okay, so instead of $4, we're charging $5, but we only sell 20 units. Our total revenue is 100. Well, it's we did have 120. We now have 100. That's minus 20. So our price increased. Our total revenue went down. That's not inelastic, which means it has to be elastic. And so we keep working our way down until we end up back to where no one wants to buy it because we're charging too much. So over here, going back just for a second, okay, elastic over here, inelastic over here. Well, we're never going to want to be in the inelastic range as a company. Well, why not? Well, if we raise the price, we'll get more revenue and we'll sell fewer units, so we'll have a lower cost. So we'll get more revenue, lower cost. That's a good thing. So companies don't operate over here, which means they have to operate over in this area. They're always operating, and then it depends on their cost and all of that. But companies will always operate in the elastic portion of the demand curve. All right, so we're going to move on. Okay, in your book, figure 47.4 gives you a nice little view of this. It actually shows that as your revenues are rising, right, we increase price and revenues rise. That's inelastic. We hit unit elastic. We go back down. These are the actual dollar amounts kind of total revenue, the changes in total revenue here. And then here's your demand curve. They link them together. They do a nice job. If you want to, take a look at that. That might help you to better understand this. Okay, what factors go into price elasticity? So factors for price elasticity, make sure you have these written down. Okay, substitutes. If there's lots of substitutes, it's going to be elastic. If there's two gas stations together, is there a substitute? Yeah, it's the one right next door. So it's going to be very elastic. Somebody tries to raise their price, you're going to just go to the other place. Okay, so substitutes make it more elastic. Okay, so greater the substitutes, greater the elasticity. Okay, luxury or necessity. If I have to buy something, okay, for instance, if we think about gas in total, I have to buy gas. What if all the stations raise their price to from $2 to $3? I got to still have gas. I'm going to tend to buy it because it's a necessity. Okay, so necessity tends to make it inelastic. The price of, I could go to Europe for $500, now it's $1,000. Well, I wanted to go to Europe because it'd be fun, but it got really expensive all of a sudden, and so that's a luxury I'm far less likely to go. Okay, share of income spent on a good. Okay, I was going to buy a car and it was going to be $20,000. Okay, and let's say I make $50,000 a year, and I'm like, whew, that's pretty expensive, but I can swing it. And then I look, well, you know what I really want is I want one of those really nice Corvettes. Okay, because I'm getting pretty old, and you see, you know, Corvettes are mostly driven by old guys like me. Not sure why, but they are. Probably because they can afford them. But in this case, the Corvette's $70,000. I only make $50,000 a year. Ouch. That's a really high percentage of my income, like over 100. And so I'm going to be very sensitive on those more expensive items. So the greater the percentage of your income, the more elastic anything will become. Okay? And then this amount of time thing, it tends to be talking more about supply. Think about it. If they said, well, we need to double the supply of eggs tomorrow. It's like, we can't do that. We only have so many chickens. What if you said, well, we needed to double the supply of eggs 6 months from now? Well, guess what? Chickens grow super fast. They get big and they start laying eggs like crazy. In 6 months, we probably could double the number of chickens if it made financial sense. Okay? So time period would increase the elasticity of the supply of chickens. So that's the last one. Okay, so you got those 4 written down, hopefully. All right, so let's ask a couple of questions. Which of the following would cause the demand for a good to be relatively inelastic? Pause the video. And we're back. Okay, so we want to know relatively inelastic. That means we have to have it, right? Large number of close substitutes. No, right? Expenditure on the good represents a large share. Now that's the income effect. That's bad. Okay. There's ample time to adjust price changes. Now that makes it more elastic. The good is a necessity. Boy, that looks good. I think that's probably our answer. And the price of good is in the upper left section of a linear demand curve. Now we already said up here that's elastic, inelastic, and there in the midpoint is unit elastic. So no, so the answer is D. Moving on. Which of the following is correct for price increases? Okay, so we're going to increase the price. Pause the video. All right, if demand is inelastic, total revenue will decrease. Okay, now remember, we're going price increases, then total revenue. Okay, well, if it's inelastic, it's going to increase. So that's wrong. Okay, so price increases. If it's elastic, total revenue will decrease. Pretty sure that's correct. Okay, C. When the demand is unit elastic, total revenue will be unchanged. That's wrong. Unchanged, that's wrong. Elastic increase, now it's inelastic, right? Where it increases, inelastic, right? Because it looks like an I. Price increases, total revenue increases, that looks like an I, so that'd be inelastic. Okay, so your answer is B. Number 5, total revenue is maximized when demand is, pause the video. You got it? You're not cheating, right? Okay. And it's unit elastic, right? Total revenue is maximized. Remember that curve went like this, then back like that? That's the point of unit elastic. So your total revenue is maximized when it's unit elastic. Okay, couple of more things. Table 48.1. This thing is awesome, okay? Make sure you make a note of this. I'd go take a copy, a photocopy, or print this out or whatever. Keep this, because this has all the details. This goes through price elasticity of demand, cross-price elasticity. This is talking about 2 different products. What happens when we increase, what happens to jelly when we increase the price of peanut butter? Well, it goes down, right? How much does it go down? Well, that's cross-price elasticity. And once again, the change in quantity is there. Okay, it also has income elasticity of demand, price elasticity of supply. It's a great little chart. Make sure you have a copy and you study it a little bit, see if it makes sense to you. And the last thing we want to talk about is the price elasticity of supply. Okay, and so supply can be more or less elastic based on availability of inputs, right? Chickens. If I need more chickens, I can get them pretty quick, right? Not too long. But how available are more chickens, or if you need cars, more steel, and so forth. The time period involved, we talked about this one, right? More chickens is, we get more chickens in 6 months. We can't get them in 6 days. Okay, the short run supply elasticity is more elastic than the market period. Depend on, yeah, whatever. Okay, that's in there. Not real important. Long run supply elasticity. This is the most elastic, which makes sense because if something becomes, if you can sell something for a lot more, you can do everything in your power to create more of them. Right now, we're seeing it with electric cars, right? We're getting more and more electric cars because they're figuring it out, getting it better and better and better. So in the long run, the elasticity supply of electric cars is increasing because they have enough time. And agriculture is a great example of the importance of time. If corn's way more expensive than wheat, what are wheat farmers going to start doing? Well, to the extent they can, they're going to start growing corn, but they can't do that in a day. But if you give them a year, they'll be growing something different. Okay, and so your supply, right? Perfectly inelastic, perfectly elastic, That's relatively inelastic. So a lot like the demand curves, just supply curves are upsloping instead of downsloping. So that's just kind of a picture there of the elasticity of supply. Okay, so we've got one or two questions left. Cross price elasticity between two goods is negative, means the two goods are what? Okay, so think about that. We're cross price elasticity, two goods. Pause the video. And we're back. Okay, so good A, price of peanut butter increases. What happens to the quantity of jelly? We buy less jelly, right? What are those two goods, right? So this is going to be negative. One increases, other one decreases. Those are complements. If in order to buy jelly, I got to buy peanut butter because jelly's kind of gross by itself. And so I'm always going to be buying peanut butter. If it gets more expensive, I'm going to buy less peanut butter. I'm going to buy less jelly too. So complement goods, cross-price elasticity are negative. They're complements. If they're positive, they're substitutes. Price of Coke goes way up. What happens to Pepsi? The quantity of Pepsi goes up. Substitutes, Pepsi wants Coke to charge more. They may not cooperate. Okay, last one, income elasticity of demand for a normal good. Okay, so my income goes up. What happens to my demand for most goods? And you pause the video, right? And the answer is, it's going to be positive, right? The more money you make, the more stuff you buy. Okay, so that's the basics of elasticity. And so Latham is out. We'll see you next time.